Welcome to the I Can't Sleep podcast, where I help you drift off one fact at a time. I'm your host, Benjamin Boster, and today's episode is about lighting. Lighting, or illumination, is the deliberate use of light to achieve practical or aesthetic effects. Lighting includes the use of both artificial light sources like lamps and light fixtures, as well as natural illumination by capturing daylight. Daylighting, using windows, skylights, or light shelves, is sometimes used as the main source of light during daytime in buildings. This can save energy in place of using artificial lighting, which represents a major component of energy consumption in buildings. Proper lighting can enhance task performance, improve the appearance of an area, or have positive psychological effects on occupants. Indoor lighting is usually accomplished using light fixtures and is a key part of interior design. Lighting can also be an intrinsic component of landscape projects. With the discovery of fire, the earliest form of artificial lighting used to illuminate an area were campfires or torches. As early as 400,000 years ago, fire was kindled in the caves of Peking Man. Prehistoric people used primitive oil lamps to illuminate surroundings. These lamps were made from naturally occurring materials such as rocks, shells, horns, and stones, were filled with grease, and had a fiber wick. Lamps typically used animal or vegetable fats as fuel. Hundreds of these lamps, hollow-worked stones, have been found in the Lascaux caves in modern-day France, dating to about 15,000 years ago. Oily animals, birds and fish, were also used as lamps after being threaded with a wick. Fireflies have been used as lighting sources. Candles and glass and pottery lamps were also invented. Chandeliers were an early form of light fixture. A major reduction in the cost of lighting occurred with the discovery of whale oil. The use of whale oil declined after Abraham Gessner, a Canadian geologist, first refined kerosene in the 1840s, allowing brighter light to be produced at substantially lower cost. In the 1850s, the price of whale oil dramatically increased, more than doubling from 1848 to 1856 due to shortages of available whales, hastening whale oil's decline. By 1860, there were 33 kerosene plants in the United States, and Americans spent more on gas and kerosene than on whale oil. The final death knell for whale oil was in 1859, when crude oil was discovered and the petroleum industry arose. Gas lighting was economical enough to power street lights in major cities, starting in the early 1800s, and was also used in some commercial buildings and in the homes of wealthy people. The gas mantle boosted the luminosity of utility lighting and of kerosene lanterns. The next major drop in price came about in the 1880s with the introduction of electric lighting in the form of arc lights for large space and street lighting, followed by incandescent light bulb-based utilities for indoor and outdoor lighting. Over time, electric lighting became ubiquitous in developed countries. Segmented sleep patterns disappeared. Improved nighttime lighting made more activities possible at night, and more street lights reduced urban crime. Lighting fixtures come in a wide variety of styles for various functions. The most important functions are as a holder for the light source, to provide directed light, and to avoid visual glare. Some are very plain and functional, while some are pieces of art in themselves. Nearly any material can be used so long as it can tolerate the excess heat and is in keeping with safety codes. An important property of light fixtures is the luminous efficacy, or wall plug efficiency, meaning the amount of usable light emanating from the fixture per used energy, usually measured in lumen per watt. A fixture using replaceable light sources can also have its efficiency quoted as the percentage of light passed from the bulb to the surroundings. The more transparent the lighting fixtures are, the higher the efficacy. Shading the light will normally decrease efficacy, but increase the directionality and the visual comfort probability. Color temperature for white light sources also affects their use for certain applications. The color temperature of a white light source is the temperature in kelvins of a theoretical black body emitter that most closely matches the spectral characteristics, spectral power distribution of the lamp. An incandescent bulb has a color temperature around 2800 to 3000 kelvins. Daylight is around 6400 kelvins. Lower color temperature lamps have relatively more energy in the yellow and red part of the visible spectrum, while high color temperatures correspond to lamps with more of a blue-white appearance. For critical inspection or color matching tasks, or for retail displays of food and clothing, the color temperature of the lamps will be selected for the best overall lighting effect. Lighting is classified by intended use as general, accent, or task lighting, depending largely on the distribution of the light produced by the fixture. Task lighting is mainly functional and is usually the most concentrated for purposes such as reading or inspection of materials. For example, reading poor quality reproductions may require task lighting levels up to 1500 lux, 140 foot candles, and some inspection tasks or surgical procedures require even higher levels. Accent lighting is mainly decorative, intended to highlight pictures, plants, or other elements of interior design or landscaping. General lighting, sometimes referred to as ambient light, fills in between the two and is intended for general illumination of an area. Indoors, this would be a basic lamp on a table or floor, or a fixture on the ceiling. Outdoors, general lighting for a parking lot may be as low as 10 to 20 lux, since pedestrians and motorists already used to the dark will need little light for crossing the area. Downlighting is the most common, with fixtures on or recessed in the ceiling casting light downward. This tends to be the most used method, used in both offices and homes. Although it is easy to design, it has dramatic problems with glare and excess energy consumption due to large number of fittings. The introduction of LED lighting has greatly improved this by approximately 90% when compared to a halogen downlight or spotlight. LED lamps or bulbs are now available to retrofit in place of high energy consumption lamps. Uplighting is less common, often used to bounce indirect light off the ceiling and back down. It is commonly used in lighting applications that require minimal glare and uniform general illuminance levels. Uplighting indirect uses a diffuse surface to reflect light in a space and can minimize disabling glare on computer displays and other dark, glossy surfaces. It gives a more uniform presentation of a light output in operation. However, indirect lighting is completely reliant upon the reflective value of the surface. While indirect lighting can create a diffused and shadow-free light effect, it can be regarded as an uneconomical lighting principle. Front lighting is also quite common, but tends to make the subject look flat, as it casts almost no visible shadows. Lighting from the side is less common, as it tends to produce glare near eye level. Backlighting, either around or through an object, is mainly for accent. Backlighting is used to illuminate a background or backdrop. This adds depth to an image or scene. Others use it to achieve a more dramatic effect. Forms of lighting include alcove lighting, which, like most other uplighting, is indirect. This is often done with fluorescent lighting, first available in the 1939 World's Fair, or rope light, occasionally with neon lighting, and recently with LED strip lighting. It is a form of backlighting. Soffit or close-to-wall lighting can be general or a decorative wall wash, sometimes used to bring out texture like stucco or plaster on a wall, though this may also show its defects as well. The effect depends heavily on the exact type of lighting source used. Recessed lighting, often called pot lights in Canada, can lights or hi-hats in the U.S., is popular, with fixtures mounted into the ceiling structures so as to appear flush with it. These downlights can use narrow beam spotlights or wider angle floodlights, both of which are bulbs having their own reflectors. There are also downlights with internal reflectors designed to accept common A-lamps light bulbs, which are generally less costly than reflector lamps. Downlights can be incandescent, fluorescent, HID, high-intensity discharge, or LED. Track lighting, invented by Lightolier, was popular at one period of time because it was much easier to install than recessed lighting, and individual fixtures are decorated and can be easily aimed at a wall. It has regained some popularity recently in low-voltage tracks, which often look nothing like their predecessors because they do not have the safety issues that line voltage systems have, and are therefore less bulky and more ornamental in themselves. A master transformer feeds all of the fixtures on the track or rod with 12 or 24 volts, instead of each light fixture having its own line to low voltage transformer. There are traditional spots and floods, as well as other small hanging fixtures. A modified version of this is cable lighting, where lights are hung from or clipped to bare metal cables under tension. A sconce is a wall-mounted fixture, particularly one that shines up and sometimes down as well. A torchère is an uplight intended for ambient lighting. It is typically a floor lamp, but may be wall-mounted like a sconce. Further interior light fixtures include chandeliers, pendant lights, ceiling fans with lights, close-to-ceiling or flush lights, and various types of lamps. The portable or table lamp is probably the most common fixture found in many homes and offices. The standard lamp and shade that sits on a table is general lighting, while the desk lamp is considered task lighting. Magnifier lamps are also task lighting. The illuminated ceiling was once popular in the 1960s and 1970s, but fell out of favor after the 1980s. This uses diffuser panels hung like a suspended ceiling below fluorescent lights, and is considered general lighting. Other forms include neon, which is not usually intended to illuminate anything else, but to actually be an artwork in itself. This would probably fall under accent lighting, though in a dark nightclub it could be considered general lighting. In a movie theater, steps in the aisles are usually marked with a row of small lights for convenience and safety when the film is started and the other lights are off. Traditionally made up of small low wattage, low voltage lamps in a track or translucent tube, these are rapidly being replaced with LED-based versions. Outdoor lighting is used for a number of purposes, including lighting areas, functional lighting, advertising, and decoration. A large-scale study in Germany in 2021 found that the most common light source in public areas was leakage from private windows, 48%, followed by street and path lights, 12.8%, commercial shop windows, 7.4%, signs, 5.6%, and lights mounted on the exterior sides of buildings, 5.3%. Street lights are used to light roadways and walkways at night. Floodlights can be used to illuminate work zones or outdoor playing fields during nighttime hours. Beacon lights are positioned at the intersection of two roads to aid in navigation. Security lighting is installed with the intention of preventing crime and is often extremely bright. Entry lights are often used outside to illuminate and signal the entrance to a property and are sometimes installed for decorative purposes. Underwater accent lighting is sometimes used for koi ponds, fountains, swimming pools, and the like. All forms of outdoor lighting contribute to light pollution, although some lighting practices are associated with greater environmental impacts than others. Vehicles typically include headlamps and taillights. Headlamps are white or selective yellow lights placed in front of the vehicle, designed to illuminate the upcoming road and to make the vehicle more visible. Many manufacturers are turning to LED headlights as an energy-efficient alternative to traditional headlamps. Tail and brake lights are red and emit light to the rear so as to reveal the vehicle's direction of travel to following drivers. White rear-facing reversing lamps indicate that the vehicle's transmission has been placed in the reverse gear, warning anyone behind the vehicle that it is moving backwards or about to do so. Flashing turn signals on the front, side, and rear of the vehicle indicate an intended change of position or direction. In the late 1950s, some automakers began to use electroluminescent technology to backlight their cars' speedometers and other gauges, or to draw attention to logos or other decorative elements. Commonly called light bulbs, lamps are the removable and replaceable part of a light fixture, which converts electrical energy into electromagnetic radiation. While lamps have traditionally been rated and marketed primarily in terms of their power consumption, expressed in watts, proliferation of lighting technology beyond the incandescent light bulb has eliminated the correspondence of wattage to the amount of light produced. For example, a 60-watt incandescent light bulb produces about the same amount of light as a 13-watt compact fluorescent lamp. Each of these technologies has a different efficacy in converting electrical energy to visible light. Visible light output is typically measured in lumens. This unit only quantifies the visible radiation and excludes invisible infrared and ultraviolet light. A wax candle produces on the close order of 13 lumens. A 60-watt incandescent lamp makes around 700 lumens, and a 15-watt compact fluorescent lamp produces about 800 lumens. But actual output varies by specific design. Rating and marketing emphasis is shifting away from wattage and towards lumen output to give the purchaser a directly applicable basis upon which to select a lamp. Lamp types include ballast. A ballast is an auxiliary piece of equipment designed to start and properly control the flow of power to discharge light sources, such as fluorescent and high-intensity discharge (HID) lamps. Some lamps require the ballast to have thermal protection. Fluorescent light, a tube coated with phosphor containing low-pressure mercury vapor that produces white light. Halogen, incandescent lamps containing halogen gases such as iodine or bromine, increasing the efficacy of the lamp versus a plain incandescent lamp. Neon, a low-pressure gas contained within a glass tube. The color emitted depends on the gas. Light-emitting diodes. Light-emitting diodes, LED, are solid-state devices that emit light by dint of the movement of electrons in a semiconductor material. Compact fluorescent lamps. CFLs are designed to replace incandescent lamps in existing and new installations. Lighting design, as it applies to the built environment, is known as architectural lighting design. Lighting of structures considers aesthetic elements as well as practical considerations of quantity of light required, occupants of the structure, energy efficiency, and cost. Artificial lighting takes into account the amount of daylight received in a space by using daylight factor calculations. For simple installations, hand calculations based on tabular data are used to provide an acceptable lighting design. More critical or complex designs now routinely use computer software, such as Radiance, for mathematical modeling, which can allow an architect to quickly and accurately evaluate the benefit of a proposed design. In some instances, the material used on walls and furniture play a key role in the lighting effect. For example, dark paint tends to absorb light, making the room appear smaller and more dim than it is, whereas light paint does the opposite. Other reflective surfaces also have an effect on lighting design. Lighting illuminates the performers and artists in live theater, dance, or musical performance, and is selected and arranged to create dramatic effects. Stage lighting uses general illumination technology and devices configured for easy adjustment of their output characteristics. The setup of stage lighting is tailored for each scene of each production. Dimmers, color filters, reflectors, lenses, motorized or manually aimed lamps, and different kinds of flood and spotlights are among the tools used by a stage lighting designer to produce the desired effects. A set of lighting cues are prepared so that the lighting operator can control the lights in step with the performance. Complex theater lighting systems use computer control of lighting instruments. Motion picture and television production use many of the same tools and methods of stage lighting. Especially in the early days of these industries, very high light levels were required, and heat produced by lighting equipment presented substantial challenges. Modern cameras require less light, and modern light sources emit less heat. Measurement of light, or photometry, is generally concerned with the amount of useful light falling on a surface and the amount of light emerging from a lamp or other source, along with the colors that can be rendered by this light. The human eye responds differently to light from different parts of the visible spectrum. Therefore, photometric measurements must take the luminosity function into account when measuring the amount of useful light. The basic SI unit of measurement is the candela, CD, which describes the luminous intensity. All other photometric units are derived from the candela. Luminance, for instance, is a measure of the density of luminous intensity in a given direction. It describes the amount of light that passes through or is emitted from a particular area and falls within a given solid angle. The SI unit for luminance is candela per square meter. The CGS unit of luminance is the stilb, which is equal to 1 candela per square centimeter, or 10 kilocandela per meter squared. The amount of useful light emitted from a source of the luminous flux is measured in lumen, LM. The SI unit of illuminance and luminous emittance, being the luminous power per area, is measured in lux. It is used in photometry as a measure of the intensity, as perceived by the human eye, of light that hits or passes through a surface. It is analogous to the radiometric unit watts per square meter, but with the power of each wavelength weighted according to the luminosity function, a standardized model of human visual brightness perception. In English, lux is used in both singular and plural. Visual comfort often entails the measurement of subjective evaluations. Several measurement methods have been developed to control glare resulting from indoor lighting design. The Unified Glare Rating, UGR, the Visual Comfort Probability, and the Daylight Glare Index are some of the most well-known methods of measurement. In addition to these new methods, 4 main factors influence the degree of discomfort glare: the luminance of the glare source, the solid angle of the glare source, the background luminance, and the position of the glare source in the field of view must all be taken into account. To define light source color properties, the lighting industry predominantly relies on 2 metrics: correlated color temperature, CCT, commonly used as an indication of the apparent warmth or coolness of the light emitted by a source, and color rendering index, CRI, an indication of the light source's ability to make the objects appear natural. However, these 2 metrics developed in the last century are facing increased challenges and criticisms as new types of light sources, particularly light-emitting diodes, LEDs, become more prevalent in the market. For example, in order to meet the expectations for good color rendering in retail applications, research suggests using the well-established CRI along with another metric called Gamut Area Index, GAI. GAI represents the relative separation of object colors illuminated by a light source. The greater the GAI, the greater the apparent saturation or vividness of the object colors. As a result, light sources which balance both CRI and GAI are generally preferred over ones that have only high CRI or only high GAI. Dosimeters measure an individual's or an object's exposure to something in the environment, such as light dosimeters and ultraviolet dosimeters. In order to specifically measure the amount of light entering the eye, personal circadian light meter called the dosimeter has been developed. This is the first device created to accurately measure and characterize light, intensity, spectrum, timing, and duration entering the eye that affects the human body's clock. The small head-mounted device measures an individual's daily rest and activity patterns, as well as exposure to short wavelength light that stimulates the circadian system. The device measures activity and light together at regular time intervals and electronically stores and logs its operating temperature. The dosimeter can gather data for up to 30 days for analysis.